Hello friends, myself Ramesh Masuna, faculty, ACE Engineering Academy. I am going to discuss GATE 2022 solutions of the subject compiler design. In GATE 2022 from the compiler design, there are totally 3 questions asked and which is consisting of totally 4 marks. And that 3 questions are from the topic syntax directed translation, parsing, and one theory question which is covering all the topics. And here there are 2 questions of 1 mark and 1 question of 2 marks, totally 4 marks asked from the compiler design subject. Here I am going to discuss all those 3 questions in a more detailed way. Look at the first question. Which of the following statements is true? Option A given, the LALR of one parser for a grammar G cannot have reduce conflict if the LR of one parser for G does not have reduce conflict. This statement is a false statement. Why? Let us consider there is one LR of one state, A tends to A dot, comma P. B tends to A dot, comma Q. This is one LR of one state. And this LR of one state, we have 2 reductions, A tends to A, B tends to A. And this first reduction is on P, second reduction is on Q. And because lookahead symbols are different, it is not considered as a reduce conflict. Suppose we do have one more LR of one state. A tends to A dot, B tends to A dot. Here also we have a reductions. Okay. Here also we have a reductions. Here you look at the lookahead is Q. Here the lookahead is P. Now this is also reductions. A tends to A reduced and B tends to A reduced. A tends to A reduction should be done in Q and this is done in P. And both reductions are on different lookahead non-terminals. This is not a conflict. It means it is not a conflict in LR of one states. If you merge these two, you can merge these two in LALR of one states because in LALR of one, we have to merge the LR of one states that have the same set of first components. A tends to A, B tends to A. Both are same. Lookheads are different. We have separated in LR of one states. Because first components are same, we have to merge in the LALR of one states. So what we have to do? A tends to A dot, B tends to A dot. Now lookaheads we have to take the union. It is P or Q. Here Q or P, we can also write P or Q. Now this is we can call LALR of one state after merging LR of one states. Now here you observe, we can call this is a reduction. This is also reduction and both are reducing in the same lookahead terminals. Now I can call this is RR conflict, reduce conflict. What does it mean? Even there is no LR, even there is no RR conflict in LR of one states, merging LR of one states into LALR of one may causes RR conflict, But what the statement is given? The LALR of one parser for a grammar G cannot have reduce conflict, but there is a possibility of having reduce conflicts. That's why option A is incorrect. Option B, symbol table is accessed only during the lexical analysis. Here it is given only, but symbol table can be accessed by other phases of a compiler also. Like let us say an example, in semantic analysis, it is checking the type checking. So what is the type of the operand that can be verified in the symbol table only? So means we can say even semantic analysis also will use the symbol table. But what it is given? Symbol table is accessed only during the lexical analysis because only given. Option B is the false statement. Option C, data flow analysis is necessary for runtime memory management. And actually what for data flow analysis? Data flow analysis for the optimization purpose, not for the runtime memory management purpose. That's why option C is wrong. Because A, B, C is wrong, D definitely could be the right answer because it is an MCQ question. What is a D? LRF1 parsing is sufficient for deterministic context-free languages. This is a direct statement and this is a correct statement stating that LRF1 parsing is sufficient for deterministic context-free languages. That is a proper statement. So, answer for this question is option D. Here it is a question asked based on the parsing techniques, that is based on the LRF0 items. Have a look of the question. Consider the grammar with plus star open close ID are the terminals and this is a grammar given. And given if I0 is a set of two LRF0 items. What are the LRF0 items? S dash tends to S dot and S tends to S dot plus R. This is I0. It is given. Then go to of closure of I0 comma plus is contains dash number of items. What is closure of I0? Now closure set means what are the all items that we can include in the I0. Here dot already reaches to the end. Because dot reaches to the end, no more items to be added. Here you can see after dot we have only just plus because dot plus is a terminal given clearly. Because dot terminal, it is not going to add any more items into the I0, means closure of I0 is I0 itself. We can say closure of I0 is I0 itself. Now look at go to of I0 comma plus. It means you have to move dot one position to the right with respect to plus. If you move dot one position to the right with respect to plus, what are the items are possible? Now look at S tends to S plus dot R possible. Because S tends to S plus dot R possible. Because dot R, we have to add R productions into the same set. What is R productions? R tends to dot R star P, R tends to dot P, and we have to add P productions also. P tends to dot open S close and P tends to dot ID, right? Any more items to be added? No more items to be added. Now what was the question? Go to of closure of I0 is I0, go to of I0 comma plus contains exactly dash items. How many items? 1, 2, 3, 4, 5. So how many items are possible? 5 items are possible. So answer for this question is 5. Here it is a question based on syntax directed translation, and here it is given a grammar along with the translation rules. Now the grammar is S tends to S hash T, S tends to T, T tends to T percentile R, T tends to R, R tends to ID, and whatever is mentioned in the parenthesis are called the translation rules. Here clearly given, here hash and percentile are operators and ID is a token that represents an integer and ID dot value represents the corresponding integer value. The set of non-terminals is strp. Anyhow, non-terminals are going to be represented with a capital letters. And a subscripted non-terminal indicates an instance of the non-terminal. Means you don't think that S and S1 are not different non-terminal. S1 is an instance of S. Just to show clearly the meaning of the translation rules, here it is given a subscripted number. That's why we can call the subscripted non-terminals are the instances. Okay, using this translation scheme, the computed value of S dot val for the root of the parse tree for the expression, here some expression is given, okay, is what is the value of this expression? We have to find it. Okay, how to do this? We have to construct a parse tree for this input sentence using the grammar. Next, we have to evaluate the parse tree according to the translation rules and we have to find S dot val for the root of a parse tree. Chalo, I will be copying this input sentence in my next slide. 20 hash 10 percentile 5, 10 percentile 5, hash 8 percentile 2 percentile 2, hash 8 percentile 2 percentile 2. This is an input sentence. Now we have to construct a parse tree for this input sentence. How to construct a parse tree for this input sentence? Starting with the starting non-terminal S. Now look at S is having S hash T, S tends to T, two productions. Because in my input sentence we have a hash, we have to apply the first production. S tends to S hash T. S tends to S hash T. Next, one hash is derived. We have to have one more hash. To have one more hash, what we have to do? S tends to S hash T. Now just observe, we derived two hashes. Now this is the first hash. To the left of first hash we have S. With S we have to derive 20. So to derive 20 with S, we have a production S to T, T to R, R to ID. S to T, T to R, R to ID. What is ID? ID should be 20. Now 20 hash is derived. Here next we have to go with non-terminal T. With T we have to derive 10 percentile phi. Now to get 10 percentile phi we have to apply T production, T percentile R. Now go with T to be replaced with T percentile R, so that we derived percentile symbol. Now with T we have to get 10, so T should be replaced with R, R should be replaced with 10. 10 is derived. And with R we have to get phi, so R should be replaced with phi. This is derived, hash is derived. Now with T we have to get 8 percentile 2 percentile 2. We have to apply T production. We have a T production T percentile R. One percentile is derived. We wanted to have one more percentile, so we have to go with T percentile R. So both the percentiles are derived. Now this T should be replaced with R, R should be replaced with 8. This R should be replaced with 2, this R should be replaced with 2. Done. So I have derived a parse tree for the input sentence given. What is the question? We need to find SDAT val for the root of a parse tree. In order to derive the val for root of the parse tree, we have to annotate the parse tree using the attributes in the semantic rule. Now, what are the attributes are there for the non-terminal str? For str, the attribute attached is val. Now, just I am writing V just to indicate it is a val. Okay. Yeah, here attribute is attached to each grammar symbol. Now, I just annotated. And we can say this is annotated parse tree if values are applied to the attributes in the parse tree. Now look at R tends to 20. R tends to 20 means R tends to ID. What semantic rule is associated with R tends to ID? You look at R val equal ID val. That is a semantic rule. So means R val equal ID val. ID val is the respective integer value. It is given. So it is 20. So wherever R tends to ID production is there, that R value is the ID value. R value is ID value. Here it is 5. Here it is 8. Here it is 2. Here it is 2. Okay. Next, just look at the production T tends to R. T tends to R had a semantic rule T val equal R val. T val equal to R val means it is going to be 20. Here it is 10. Any other productions? Here it is 8. That's it. Next, here you look at S tends to T production. What is the semantic associated with S tends to T? S val equal T val. S val equal T val means this is going to become 20. That's it now? Yes. Now, look at here we have a T percentile R. T percentile R. T tends to T percentile R. What is the semantic associated with the T tends to T percentile R? T val equal T1 val divided with R val. T val divided with R val. Look at T val is 10 divided with R val is 5. 10 divided by 5 which is equals to 2. Here you can look 8 divided by 2 which is equals to 4. 4 divided by 2 which is equals to 2. Next, what production is applied? S tends to S hash T. What semantic rule is there? S val equal S val into T val. That hash is representing the multiplication. S val into T val. Look at 20 into 2, it is 40. Now 40 into 2, which is equals to 80. Now what is the question? What is the S dot val for the root of the parse tree for this input sentence? The S dot val for the root of a parse tree for this input sentence is 80. So answer for the question is 80 is the correct answer for the question. This is one way of solving the question. How we have solved? Constructed a parse tree and evaluated the parse tree according to the semantics. This is one way. Other way of solving the question is very simple. First, you have to understand the grammar. Here you observe the hash is a terminal associated with a starting non-terminal. So that hash is having the least precedence. Hash is least precedence, or we can call lowest precedence. And the percentile is coming after S to T, T with percentile is coming. Means T is going to appear in the bottom of the tree. Sorry, percentile is going to appear in the bottom of the tree, so that the percentile is having highest precedence. And you also observe here S tends to S hash T. So we can call it is left recursive, because leftmost symbol in the RHS is same as LHS. We can call left recursive. Then the associativity of hash is the left associativity. And look for the percentile. T tends to T percentile R. We can call even percentile is also left associativity. So we understood the precedence and associativity. Now we can evaluate the expression, find the answer easily. Now what is the expression? 20 hash 10 percentile 5 hash 8 percentile 2 percentile 2. How expression is going to be evaluated? Highest precedence operator is going to be evaluated first. That is percentile is the highest precedence. Now 10 percentile 5, it is 2, and left associative means leftmost operator is going to be evaluated first. 8 percentile to 4, now 4 percentile to 2. Now it becomes 20 hash 2 hash 2. Next hash, lowest precedence. Now hash has a semantic rule star, so means multiplication. Because more than one hash is there, and it is going to be evaluated according to the associativity, left associativity. 20 hash 2 means 20 into 2, 40. 40 hash 2, which is equals to 80. 80 is the answer. This is another way of solving the same question in a more simpler way. But regular procedure is we have to construct a parse tree for the input sentence, evaluate the parse tree according to the semantics, and we can find the S dot val for the root of the parse tree. That is a regular procedure. But if you can understand the grammar, it is easy way of solving the question. Hope you understood. Thank you.